Android workshop is there. That is much more important because Android initially seems very difficult and it is having a lot much scope also. So please don't miss that workshop. I personally have experienced the workshop from the Adifico. I know the way they are dealing with the details, and it is quite interesting that they will conduct hands-on also. Still, it is online, but still, you must attend that workshop. So, during the chat window, I will send you one link. So please fill that survey form. It will take at most 5 minutes, and within 5 minutes, we will start our lecture. In the chat window, I have given a link. So please go through that link, fill the online survey, and let me know. It means what is your opinion about the survey? That is online survey. More 5 minutes we will wait, and then we will start our lecture. Now done. So let us start with the today's lecture. So today we are, so in the last lecture we have studied about the views. Views, these are the outputs of some query, or we can say that virtual relations which doesn't have physical existence but can be used as a relation name in the select queries. So here views, this was the output of some select query, and where any complex query is there, instead of executing or remembering that query, we are using the view concept. Now we are moving towards the updation of the views. So materialized views we have seen, how to create the views, that also we have seen. So view can be created by using create view, passing the view name, and if we wanted to rename the columns, so we can also give the new names of the columns. And as, so as keyword is used here in order to say that this name is given to the view which is generated by the output of this query. View input is always a select query. So in the select, we can pass any random query. So it is not necessary that there is no restriction to have which process or which operations we can use into select. So we can use any select query as a query to create a view. So here, whatever the nomenclature we are following for the relation, the same nomenclature is applied to the view also. So view, uh, this the name should start with any alphabet and doesn't must not be any keyword and should be a continuous without space. And we can use numerics also after the first alphabet. And each view name should be unique, and there can be multiple views on the same relation. So these points we have seen into the last lecture. Again, we have seen the definition of materialized views. So materialized views where views are giving the output of some select query. So that is always updated. It means that even though we perform the changes to the actual relations, the view will always give us the updated result. So this we have seen. So now we are moving towards whether can we perform any other DML operations onto the view. DML operations include insert, delete, and update. So here the question comes whether view can have, or a table might be having multiple columns, and that all columns may not be included into the view. Okay, let us take an instructor as a relation. So instructor relation contains ID, instructor relation contains name, department name, and salary. These four attributes are there. And if consider in the view, I have taken only salary and name of the instructor. So here now am I audible clearly? So here we were discussing about performing other DML, that is insert, update, delete operations on the view. So here let us take an example of the instructor relation. Okay. So instructor relation contains four columns: ID, name, department name, and salary. So these four columns, out of these ID is my primary key. So I will take a reference here. So here we were talking about the instructor relation, which contains ID, name, department name, and last column is salary. Okay, so these are the attributes. Okay, right now consider that this ID, okay, ID is my primary key. So let us make this as a underline. Okay, name is a not null attribute. It means every person is always having the name. So that's why during the table creation, I may assign some not null criteria. So I will give the sign convention as consider this is italic. It means this is a not null. Here department name is foreign key. Salary is also there. There is no criteria on the salary consider right now. And in the view, okay, consider view V1 is there, which is based on the instructor, which contains a department wise average salaries. So it means it is having only two columns, department name and average salary. Okay, these two columns are there into the view. Now, do you think that we can perform insertion into the view and that will reflect into the instructor? So first thing, whether question is clear. Can we perform insertion into the view V1 and those changes can be reflected into the instructor? Because view doesn't have any physical existence. This is a virtual relation. That's why V1 is not going to store any values. Right now consider there are 10 departments and I have entered data for the 11th and 12th department and some average salary I have assigned. So do you think that data insertion will also reflect into the instructor? Let us assume that data entry is also available into the department relation. In the department, that department name exists. So now the question is, can we perform insertion onto the V1? So, any answer?
Ma'am, uh, by using view only we can display or retrieve the data. We can't perform the insertion in that. We can make changes in instructor, but by using v1 only we can retrieve.
Yes. Here the things comes is that here whenever we are inserting value for some another attribute, so if consider department name I have given as a production and average salary I have given this as a 40,000 and let us assume that database I have designed such that whatever average salary is there that will be applied to the instructor. Then which value it should accept as a name and which value it should accept as a ID. So that becomes a problem. So it means that in this case, updating the view is not possible. So that's why here there are some restrictions applied onto the view updations. So here it is not a case that we cannot perform any insertion or updations to the view. We can perform the insertions via view also. So here the statement I have made is that wherever relation name can be there, view name can be. It means we are writing insert, update, delete queries by using the relation name. The same concept we can apply to the uh, insert view also. It means via view also we can insert. But there are some restrictions. Restrictions. So let us see which are the restrictions are there whenever we wanted to perform any updations to the view. So the first restriction is that So the first restriction is that here we should have only one database relation. So it means that whatever select query we are giving as an input to the view, this must have only single relation name into the from clause. So it means that if I'm writing query onto the instructor, I cannot make view, if I wanted to perform updations to the view, I cannot have more than one relations as input to the view. So this is the first restriction, that in the select query there should be only single relation name should be there. Just like here. Here I am having dip instructor relation, that is a water select query for which I am creating the view. This from clause contains only single relation name. Instead of that, if I am writing department here, then I cannot perform updations to this view because the first criteria doesn't get applied. That from clause should contains only single relation name. If there are multiple relation name, then this is a drawback, or this we cannot perform as per the given statement. Clear with the first restriction? Still, there are many. This is our first restriction. So now the next restriction is that the select clause contains only attribute names of the relation and does not have any expressions or aggregates or distinct specifications. So this is the main criteria. Okay, the select clause contains only attribute names of the relation and does not have any expressions, aggregates or distinct specifications. So let us assume this query. So here I am using the sum as a average function. Then it means that this value is representing multiple tuples, and because of which we cannot replace this multiple values with a single value. So here aggregation is not allowed whenever we are performing any changes to the view. If we are not performing any changes to this view, then it's okay that we can use the aggregate functions, etc. But whenever we are talking about the updations, insert, update and delete operations on the view, then it is mandatory that we should not have any of the aggregate functions into the select clause. Next, we should not use a keyword like distinct, etc. Okay, so distinct, this keyword also we cannot use during the updations to the view. During view creation we can, but if we wanted to perform changes to the view, we cannot perform by using this distinct keyword or neither by using the aggregate functions. And it should not have any expressions also. Expressions, it means that instead of giving the salary, if I am giving salary multiplied by 1.1, okay, so this means this is a any expression. So this is not actually referring to the column, but this is actually referring to some value which is based on the existing columns. So such expressions also are not allowed during the view updation. During view creation, these are allowed. There is no any restriction. But if we wanted to perform any insert, update, delete these operations onto the view, then these rules get applied. Clear with these two rules? Are you clear with these two rules? Only single relation into the from clause and multiple, it means expressions, distincts, these are not allowed during the select clause.
Yes, ma'am, it's clear.
Okay, anybody else is having any problem? No, I guess. So let us move to the next restriction. So the next restriction is that any attribute not listed into the select clause can be set to the null. Okay, that is, it doesn't have a not null constraint and is a part of a not part of a primary key. So okay, so this rule is somewhat difficult, so let us read this rule once more. Any attribute not listed in the select clause can be set to the null. Okay, Right now, we are using two attributes into our query, that is department name and salary. And other than this, there are two more columns into the select clause, that is ID and name. So now any attribute not listed into the select clause can be set to null. So can we set ID to the null and name to the null? Can we set ID to null and name to the null? No answer.
Ma'am.
Yes, yes.
For primary key, we can't set uh, not null constraint, but for name, it can. Means we can. Sorry.
For the name, we have given the constraint as not null.
I- if we means if we sorry, if we have given the constraint not null, then we can't say give not null constraint to name also.
Yes, that's right. So here the restriction is that I primary key, it means that here whenever I'm using, so I will move to the direct last part. So here ID, this is my primary key and name is a not null attribute. So if consider we are performing insertions for this column and this column, there is no insertion done for these two attributes. And because of this, by default data, wherever there are no values, this will replace that previous contents by using a null value. So null, it means that the value right now doesn't exist. And same way, here ID doesn't exist, that cannot be allowed. That is, I cannot allow ID to be null, and neither name is one of the compulsory attributes that is not null, and that's why I cannot have that is, it means database will not allow to have name to be null attribute. And the same concept the view uses, if it is applying value for these two attributes, this will set these attributes to the null value. So the rule says that wherever whatever the attribute listed into the view are there in the select clause, except those or those which are not included can be set to the null. If we cannot set these attributes to the null, it means we cannot create a view on those tables. We can create view, but we cannot perform update operation, that is insert, delete, etc. So this is the restrictions added to view. So here, the second last constraint says that any attribute not listed into select clause can be set to the null if, that is, it doesn't have a not null constraint and is not part of a primary. Yes, whether it is a part of primary key, there it allows for the uh, null value, but wherever primary key is there, it doesn't allow the null value. So that is also rule. So it means that ID and name should be the part of view itself. They cannot, it means these cannot be eliminated from the view if these are primary key and not null attribute. And the last constraint is that the query does not have a group by or having clause. So query should not contain any group by or having clause, because here group by, it means that we are having a single presentation for the common values, and by using that common values for a single row, we are applying some having clauses, having applying condition onto the group. And that's why this type of concept is also not allowed during the view creation wherever we wanted to perform the updation. Done?
Done? So please read this once, and within 2 minutes, read this for a once or twice, and then we'll move to the next slide. So, okay, done. Now let us move to the next point, that is a transaction. So we are on the verge of, it means whatever remaining points are there, these are actually the separate chapters are there, but we don't have all these chapters. So these are the simple SQL commands which are used for the different purposes. That's why we are covering this into SQL also. So the first concept we are going to learn is transactions. So transactions, it means that this is a single logical operation performed onto the database. And this operation may involve multiple data access. Okay. Multiple data access, it means that if I'm passing some check into the bank, it means that in order to check whether that check is valid, so it will access the database of the other or origin bank. Then it will check whether amount is there. If so, then amount will be withdrawn and then it will be deposited into my account. It means that here, and whatever my added value or the new value is there, that will be added to the it means to my account balance. So here it means that logical operation is that passing the check, and this may involve multiple steps and or multiple database access also. So single logical operation, it means that here if I divide this complete operation into number of database access or data operations, then reading the bank data, checking the validity of the check, and then uh, reducing the balance of sender and adding that balance to the receiver. Then this, we cannot divide this activity into number of steps. It means that if I'm saying that passing the check, it means out of these operations, neither I can eliminate any of the operation, neither it means half part done and then next half part will be done. It means that here whatever this complete operation is there, that should be done as a single logical operation. We cannot divide this single logical operation into multiple operations. Yes, there is a multiple data access, but this complete procedure will be taken as a single procedure only. So that's why the transactions are called as a single logical operation. So there can be multiple transactions executing simultaneously, which are accessing multiple databases or which might be accessing multiple data, etc. So this for performing operations on the database, which SQL keywords are used, that we are going to learn in this point. So let us read about this point. A transaction consists of a sequence of query and or update operations. It means we are performing updations. The SQL standard specifies that a transaction begins implicitly when SQL statement is executed. It means that transaction will begin automatically without, that is implicitly it will start. So one of the following SQL statements must end the transaction. So the ending statement for the transaction is commit while waiting. Okay. Commit is the keyword which says that right now up to this point the transaction was going on. So here the main thing is that every transaction is given a separate ID by the database for every transaction. So whenever any transaction is starting, so this will end whenever we are typing the commit and work and the transaction number. So commit is the endpoint of any transaction. Commit, it means that the changes will be also carried to the actual database. So commit work commits the current transaction, that is it makes the updates performed by the transaction become permanent in the database. So whatever the updations we have done, these are not always reflect to the database directly. So here these are made onto the separate platform, and whenever a commit work is called, then only these changes will be reflected to the database. After the transaction is committed, a new transaction is automatically started. So it means that the processor always begins for the new transaction wherever it is waiting. So this is not only commit work is the keyword. There are multiple keywords are there which are used with the transactions. So rollback work. Rollback is nothing but a undo of operations. So let's read this. Rollback work causes the current transaction to be rolled back. That is, it undoes all the updates performed by the SQL statement in the transaction. So here, this will it means this will perform undo of all the updates. Okay, whatever updates done on the database are there, this will perform the reverse operations or undo operations on all the SQL statements in the transaction. So here always whenever we are starting with the transaction, transaction always starts with the begin keyword and ends with the end start of the transaction. Okay, so thus the database state is restored to what it was before the first statement of the transaction was executed. So rollback means that undo the database changes might have taken place during this transaction, but these will be performed in reverse statement to the to come the database to the original state. Okay, so it means undo all the changes. So this for this purpose rollback work is used, and here whatever work keyword is there, it is not compulsory. This is optional keyword and will vary from database management system, from just like Oracle or MySQL, whether to use this word or not to use this word. Okay, so this is always an optional word in this rollback, etc. Next, so now there are multiple database operations are there into a single transaction. That is accessing first sender's database, checking for the validity of the check, whether any account exists or not. So here it means that these are initially some select operations are there. Then deducting the amount, that may be some output operation where we wanted to write the new balance, and then accessing the receiver's database, again read operation and changing the value, that is write operation or output operation. So it means that here whatever these all operations are there may have multiple data access. For to have multiple data access, in order to make all these operations are uh, single logical operations, always transaction starts with the begin keyword and end keyword. So allow multiple SQL statements to be enclosed between the keywords begin atomic and end. All the statements between the keywords then form a single transaction. Okay, so all these whatever between begin and end will be there, that will be considered as a transaction. So read for a minute. Next point, integrity constraints. So you might have heard this word frequently. So let me know what is mean by integrity constraint. So what is mean by integrity constraint? Integrity constraint, it means that these are the rules or some restrictions which are used in order to match database with the actual real life data. So, okay, so let us read the definition. Integrity constraints ensure that changes made to the database by the authorized users do not result in loss of data consistency. So, loss of data consistency, it means that here, if I'm passing the student's age as 16 and student has completed ME, then it means that this will not be any right data provided to the user because at this age of 16 completing the MECSE that may not be valid. So it means that here we are willing to put the restriction that whenever ME is there it should be valid. So greater than 20. Okay, it means this is not a fixed rule, but changes do not result in a loss of data consistency. Whatever database we are maintaining, that should be in a proper valid condition. That is correct, it should be correct. Thus, integrity constraints guard against the accidental damage to the database. So, whatever accidental damage is there, that we can check. Examples of integrity constraints are an instructor name cannot be null. Yes, it cannot be null. No two instructors can have same instructor ID because here ID is considered as a overall holding the information. That's why we cannot repeat ID for the every user. So each user must have a separate ID. Next, every department name in the course relation must have a matching department name in the department relation. So this integrity constraint means that whatever the courses we have taken, these might be belonging to any department. So the last statement says, second last says that if we are using department name into the course relation, so here it is assumed that every course is belonging to either one or more departments. It means that here that department should be accessible or should be available into the department relation. Next, the budget of department must be greater than $0.00. So this can be a normal function where we, if clerk by default gives any negative value, etc. So in that case, we can check whether that valid value is there or not. So let me know what is your opinion regarding this.
Am I audible? So here I was talking about the integrity constraint. So integrity constraint means that these are some rules which are applied for matching the real life data. Okay, just like for the instructor ID, for each instructor to be get differentiated separately, I may assign some ID value which cannot be repeated. So every instructor is having the name. So whenever we are maintaining the database, we must not allow the null value. So it means that these are some constraints given during the creation of the table. Okay, integrity constraint for checking the correctness of the values, we are using these rules. So here budget can be always greater than 0. That's why here also we can pass the constraint. And wherever those departments which are existing into the department relation, only courses of those departments should be allowed in the college. Other than those courses should not be allowed because there is no department exists. That's why here courses to which department that course belongs, that information also should be properly preserved. So this constraint is called as a foreign key constraint and not null, yeah, primary constraint or check constraints we can apply. So let us see. Integrity constraints are usually identified as part of the database schema design process. Okay, so whenever we are designing the schema in the design phase, there only we can apply this constraint or decide those constraints to be applied and declared as part of create table command used to create relations. So during the design process, we will decide which constraints to be put on the relation, and then during the create table command, we can pass those constraints. Or if we have already created table and again we wanted to pass some restrictions on the existing table, then here we can do this by using alter table command. But here problem with this approach is that if we have performed some insertion into that relation, then it is mandatory that whatever constraint we are applying, that constraint should be followed or should whatever relation is there, that should satisfy that new constraint. So that's why, for example, I have already created table for the instructor, and in the name I'm having instructor with triple five, and that instructor name is null. And then we are applying the constraint not null onto the name. Then it won't work because already there is a value which is violating that constraint. That's why such constraints are not allowed by the database. If we are passing the constraint, already table should be in the same constraint or table should satisfy the constraint. Okay, so let us read the last line. Can be added to an existing relation by using the command alter table, table name, add constraint. Okay, this command we can use where constraint can be any constraint on the relation, just like not null, primary key, foreign key, etc. So whatever constraint we wanted to add, we can by using the alter table command, where constraint can be constraint on the relation. When such command is executed, the system first ensures that the relation satisfies the specified constraint, that is name is not null anywhere. If does, if it does, the constraint is added to the relation. If there is no any single name with the null value, then not null constraint we can apply. If not, or there is a name with the null value, the command is rejected. Even though syntactically correct, still we cannot apply some constraint on the name. Okay. So would you like to read the slide for once? Take a minute. Now let us move to the next topic, that is constraints on a single relation. So which constraints we can apply onto the single relation? So already we have seen constraints like domain constraint where we are specifying what should be the data type and which types of the operations to be allowed by the data. So domain constraints, we are not taking the part of this. So yes, domain constraint is always there. So then there are few more constraints also, not null, unique, check. To the check, we need to pass some condition or predicate also. So the create table command may also include integrity constraint statements. That is, we are creating a table. In addition to the primary key constraint, there are number of other ones that can be included in create table command. That is, during creating the table, other than the primary key, there can be multiple constraint also which we can apply. The allowed integrity constraints include not null, unique, and check. To the check, we are passing some condition, that is a predicate. So let us see these constraints one by one. First, not null constraint. So, okay, not null, it means that that value is mandatory. Okay, it cannot take, it means this value cannot be unknown. This value is always existing. Just like for the every person living on this earth is having some name, then we can say that the name is a name is a not null attribute. So here example is given. Name varchar of size 20. This can be not null. So after definition of the column, we can apply the constraint. Similarly, in the second example also, budget numeric 12,2. Not null. This is also one of the example for the not null. Next, unique constraint. Unique where we wanted to avoid repeated values. So null value says that null value, it means that uh, some value must be there, and unique it means that that value should not get repeated. Okay. So unique allows for the null values also. Not null doesn't allow, but unique constraint allows for the null values. SQL provides an integrity constraint. So integrity constraint, just like unique AJ1, AJ2, AJM, it means multiple attributes are there. The unique specification says that attributes AJ1, AJ2, and AJM form a candidate key. That is, no two tuples in the relation can be equal on all the listed attributes. So whatever attributes are there or value set of that attribute, it should not get repeated, and that should be always unique. However, the candidate key attributes are permitted to be null unless they have explicitly been declared to be not null. So if unique allows for the null value, but if we restrict it to be not null, then only it accepts the not null value. Check constraint. So this is a new constraint which is not supported by the MySQL. So check. For example, I have been standing for a very long period into the queue. Consider along with me one of my younger relative is there, and he or she wanted to open account into the bank, and that's why as a supportive I have go. So here, whenever that young relative wanted to open the account, so during the form distribution, it will ask me how old is the guy, and if I say 16, so do you think that that account opening should be allowed at this point? So you might be thinking there are many scholarships are there. No, I'm talking about the general case where any kid with age of 16 cannot open any bank account. because here the restriction is that banking always accept the age more than 18 for any person who wanted to open the account. So it means that 18 is the minimum age limit which is given. So in the check, if I'm passing not null or null criteria, etc., still these values will appear, the value whatever the less than 18 age is there. So here we can apply the check constraint. So check constraint can check whether this value satisfies the given constraint. So if consider, if I'm saying age is the attribute, and to the age I have given the restriction that age should be always greater than 18. Then here check constraint will check this condition for the given account opening. So check this will always check this whether the minimum conditions are satisfied or not. Read the slide.
Ma'am,
Yes,
can you explain once again the check clause?
yes, I can.
Hmm.
So let us read this.
Hmm.
A common, ah,
Nothing means I
okay.
understood. Somewhat I understood.
Yes, okay. So here, a common use of check clause is to ensure that attribute values satisfy the specified condition, in effect creating a powerful type system. Okay, we wanted to create some restrictions on our system, and that's why we are applying the check constraint. For example, okay, so in the student relation, I have allowed for the class attribute also. That's okay. Student relation is there. And in the student relation, I'm having ID of the student, name of the student. Let us take department name is also there, and a class attribute is there. Okay, let us take an example of engineering. Okay, which can be the values for the class can be. So class can take the value like, class will have a value only like fy. Okay, it can have the value like sy, and it can be value like ty. And for the final year, consider by or btech. Okay, consider these are the values for the class attribute are there. So now, do you think that other than this, person should be able to add the value? So if any student, whenever entering the class name, if he enters AB or simply A or simply B, any name, as whenever we are writing this or whenever we are creating this class as a attribute, we might consider this as a var character, and not null attribute also or not null constraint also we will pass. Now, whenever value is there, so now do you have any medium to check whether value is fy, sy, ty or btech? No, this we cannot check. Whenever we are saying any data type is integer, we are allowing all the integers to be the part of that value. So it means that here, whenever we are dealing with the values, yes, integer value is allowed, but there also we wanted to put some restriction. So in that case, we can apply this constraint by using the check constraint. So what I will do, during defining the class attribute, I will check. So this is considered definition of my class attribute varchar of size consider 5 or 10 I will pass. Uh, I will check class in. Okay, check class in. So it means that this will check whatever the value user or student has entered for the class. This value should be between these four values only. Other than these four values, any other value is not allowed. Or let us take an example of the age. Okay, age. I will enter this as integer and check. I will apply that greater than, age should be greater than 20. It means that here we cannot put on any restriction onto the integer that it should be less than or greater than 20. But during the insertion into the database, we wanted to make sure that every student must be having the age as 20 because 20 is my minimum wage for the engineering. Then in that case, such restrictions we can apply by using check. If any user by default or by mistake try to enter value as 14, then that value should not be accepted by the database. That is check constraint. Clear?
Yes, ma'am, it's clear.
Sure.
Yeah, ma'am, sure. Thank you.
And this check is not allowed by the MySQL. So this will work into the Oracle, etc. MySQL doesn't allow for this criteria, that is check constraint. That's why we cannot check whether this is actually working or not. So whenever we are dealing with the any Oracle, one or two practicals we will conduct on the Oracle also online platform. Then I will show you this constraint, check constraint. So now let us move to the next, referential integrity. So referential integrity, already we have seen this concept. So wherever the values from one relation are being referred by some another relation, so during the insertion, it will check whether this value is existing into the first relation, then only the value will be allowed by the second relation. So in short, we are talking about the foreign key. So this is also one of the integrity constraints. So let us see this. Often we wish to ensure a value that appears in one relation for a given set of attributes also appear for certain set of attributes in another relation. So this is called as a referential integrity. Just like whatever departments are there into the department, those only departments should be appearing into the instructor relation as well as in the course relation. So here example is given. So this is a normal SQL syntax is there. So this is not specific to any of a database management system. Department name varchar. So this is the usual definition of the column, and then we can use the references keyword and the original relation name. Then where this column department name is there, before performing changes to its own relation, this will check whether that value is available into department. Okay. So integrity constraint violation during the transaction. So this point is actually somewhat lengthier. About this point we will see into the transaction chapter. But here main point is that during the transaction execution, for example, I'm having account A with balance equal to 1001, okay, and I'm also having account B equal to balance as 2000, okay. So now consider 1000 from A's account I wanted to transfer to the B, okay. So here during the transaction, so here the main rule is that for the balance check, amount should be greater than 1000. So many of the banks apply this rule that you should have the minimum balance as 1000. Then performing transaction of 1000, okay, that A balance should be deducted 1000 and that should be added to the B. Okay. So whenever we are performing a transaction, during the transaction also this constraints will be get applied. Okay. So constraints this will be applied during the transaction also and it will not violate this rule. Okay. So this is the first thing. And second thing is that if consider we are maintaining data about the people, okay, in the people, name of the person, then is false. So are you clear with this false? It means that if person is a male, spouse will be wife, and if person is female, the spouse will be husband. It means spouse. It means refers to the partner. Okay, but so here, so now consider that I wanted to enter data for the couple like Sanjuni. Okay, occupation teaching, and the name is Sachin. Okay, this is the data I wanted to enter. So now in this case, spouse is also a person. So it means that here, whatever the name I'm using here, name, this is a primary key here, and this is also foreign key here. Okay, foreign key means that if I'm using name Sachin here, Sachin should be already existing into the database. For the Sachin, entry will be Sachin, business, and then Sanjeev. So here it means that whenever we are entering value of these two rows, during the it will check whether Sachin is there. If not, this will not allow to enter this value. And whenever it is entering value for Sachin, it will check whether Sanjuni is there. If not, this will not allow to enter this. So in this case, during the transaction, okay, transaction means a single logical statement. So in during this case, so whenever we are inserting such types of the values, wherever recursion is there or recursive relations are there, recursive referential integrity constraints are there. So during this time, it will allow to violate the rule of foreign key, will allow to enter Sachin value even though there is no value existing into the relation. Similarly, next it is allowed to enter Sachin value and Sanjuni already we have inserted here. It means that during insertion of these two values, it will take a relaxation. Yes, transaction yet not completed, but transaction will start before the entering of the first value, that is before inserting of this value, begin the transaction, and after completion of this insertion, end the transaction. So the 4 points taken into this under this point. If initially this seems difficult, but as we study the sixth chapter, you will understand the meaning of this topic also. So I will not go much more details here. Let us go to the next point. SQL data types and schemas. So already we have studied few of the data types like integer, character, var character, numeric, float, or real, double, etc. So now whatever these data types we are learning, these are also other than those data types. So let us see the first data type, that is a date data type. So date is a actually every transaction or every database operation takes place with respect to the date. That's why date is also allowed by the database. So this is having a format varying from database system to the database system. So but usually it follows the format like day 2 digits dash or this backslash month 2 digits, and year 4 digits. Okay, so in this way, always a date is preferred or date is given. So 2 digits for the day, 2 digits for the month, and 4 digits for the year. A calendar date containing a 4-digit year, month, and day of the month. Okay, just like today we are having the 4th September, so that can be mentioned by using 04. 04 should be here, not only 4 because it is only single digit. No, here we should pass always 2 digits for the day. Next, 09, 2 digits for the month, and 2020, 4 digits for the year. Done. If we pass it like something this, so this will give us a problem. Okay. So few are having format in this way, or few may have format like month first 2 digits, then day next 2 digits, and then year. So in this way also dates can be there. Next, time. So time we are having in hours, minutes, and seconds. And with respect to the machine or it is computer device, this can take up to nanoseconds also. So time, this will give us time of day in hours, minutes, and seconds. And variant, that is time p can be used to specify the number of factorial digits for seconds. It means in the seconds, how many it means how many fractions of seconds we want, whether it should be 3 or 4 or 5 or 10, etc., that we can mention here. Next, timestamp. So this is a combination of date and time. A variant, that is timestamp p, can be used to specify the number of fractional digits for the seconds. So default used is 6. So here few of the formats are given, how date is given, how time is given, and how timestamp is given. Have a look at this. Next, default values. So default values, so these are used whenever we have set any attribute as not null, and by default it accepts some value. So this can be used in any of the SQL statements. So here, SQL allows a default value to be specified for an attribute as illustrated by the following create table statement. So here this is a create table statement, and here total credit, this is the value where initially we are setting this to the 0 value, and as we go on conducting the courses or taking the courses, this value will go on increasing. So here, whenever we wanted to set any default value, we can use a default keyword, and next to that a default value. So this is the way to specify a default value. Consider that here department name is there, and by default, if none of the faculty, any faculty is not assigned department, consider that I wanted to set this faculty to C as a department. Then here I can write this as a CSE. This is how we are assigning the default value for the department name. Next, index creation. Regarding index, index is a data structure, okay, allowed by the database. So the way we are having index for the textbook, where initially we will be listed with the chapters, and there is one more index at the end, which is alphabetically, and wherever any word is there, that concept we can find on that particular page. So similarly, here also the index is maintained by the database, and index can be based on some attribute. So here we are having index on the student ID. So in the index, always we are having attributes in ascending order and also the reference for that actual record. It means here if we are having index entry, so first any entry available, then we can check into the index. And if it is available, we can get the address directly and then we can access that element. So here this is a data structure which is used for the fast access of the database. There are multiple types are there. So let us see how to create an index. So this point also we will cover during the fifth chapter because fifth chapter indexing and hashing is completely based on these two techniques only. That's why details we will see during the fifth chapter. But let us see the first definition of the creating index. So here while creating the index, we can use the keyword create index, name of the index, and then here on keyword we should use here. On keyword. This keyword allows us on which attribute we wanted to create a index. So okay, on keyword is always used. So on, and from the student relation on ID attribute we wanted to create the index. So this is how we are creating the index. Next, large object types. So here, whatever data types, etc., we have seen all these data types are dealing with the text data only. So what if we are having the multimedia data, just like any image or just like any video clip or just like any audio clip, etc. So here, whatever this type of data is there, multimedia data takes a lot much time for the processing, and that's why this will also take a lot much space also. So for this purpose, database allows for the different data types to be used for referring to these objects or this type of data. So large object type, this type of data, it means we are having a multimedia data or any file data, etc. So there can be multiple types. That is, SQL provides large object data types for character data. Okay, character data, CLOB stands for the character large object type. Then we can have binary data or we can have binary data and character data only. So these are called as glob and blob. So here also while defining the structure, we should mention which type of data we are using and what can be the maximum size. Okay, so this will allow us to create a large object type. Next, user defined types. User defined type, it means that in the programming languages we are having a concept like structure, we are having a class, etc. It means that these are the user defined data types are there, or as per the user's need, these can be used to store the data or data set, etc. Similarly, database also allows users to create its own database types. So let us see this. SQL supports two forms of the user defined data types. The first form, which we cover here, is called distinct types. It means which type of data we can store. The other form called structured data types allows a creation of complex data types with nested record structures, arrays, and multi-sets. So, okay, we know that arrays, structure, class, or multi-set, these are the derived data types, and these are allowed by the database. So, let us see this one by one. So, the create type clause can be used to define new types. It means whenever uh, we wanted to create uh, user defined data type, then we can use this create type command. So create type dollar as numeric 12 comma 2. and final. So final, this keyword is used in order to restrict it from getting inherited. So this dollar and pounds we can use. So if we wanted to use this, then during table creation or in other tables, we can use them like, sorry, any create table is there and there we wanted to make a currency or any amount we can pass this as a dollar directly as a any other data type just like int, character, etc. During create type, we are defining the size. That's why size is not required here to be passed as argument. Directly amount dollar, this will make use of the type already created as a dollar. So what can be the difference between normal data types and this uh, create type or user defined data types? So let us see this. Previously, domain, it means introduced in SQL 92, which can add integrity constraints to an underlying type. It means whatever our types were there, we can apply the integrity constraint. For example, we could define domain d dollar as a follows. So here, this is a type created. So it means we are creating a domain here. Domain, this is a separate concept and type is a separate concept. Okay. So differences. Domain can have constraints such as not null specified on them and can have default values defined for variables of domain types. It means here we are applying the constraints which will get applied onto the dollar. But if we define a type, that constraint we cannot add to the type. Whereas user-defined types cannot have constraints or default values specified on them. Okay, first difference between domain and type. User-defined types are designed to be used not just for specifying the attribute type, but also in procedural extensions to the SQL where it may not be possible to enforce constraints. So here, if we, it means constraints cannot be applied, then only we can go for the type. So create type, this can be used wherever we want it. We are unable to enforce some constraints, then we can allow. And here, default values and constraints can be allowed by the domain. Domains are not strongly typed. As a result, values of one domain can be assigned to the values of another domain type as long as the underlying types are compatible. So this is one of the examples given for this. Create domain, early salary. So numeric, this is the complete table, column name is there. Constraint, salary value test. So here value should be greater than 29,000. So this constraints we can apply by using a create domain command. Next, create table extensions. How we can create table without knowing the definition, that is create table or any other definitions, etc. So here, if consider we are having already the existing structure of a table, and with the same structure, if you wanted to create a table, then we can by using this syntax. Create table temp instructor, that is the original name, like instructor. Okay, so here actually the name is This is the name. Create table temp instructor, a complete name of the relation, like instructor. So this, whatever constraints on instructor are there, all those constraints will be get applied on the temp instructor also, and same column names, same constraints, etc. will be matching. Next point, authorization. So authorization, we may assign several forms of authorization on parts of a database. Just like as per the user, we are changing the access policies. Similarly, here also authorization, it means that different user is given different rights to read that database. And operations can be also vary. So authorization on data includes authorization to read data, to insert new data, to update data, or delete data. So these are the types of the authorization that on which we can apply or we can perform these operations on the data. Next, each of these types of authorization is called a privilege, or privilege is also called as a right. We may authorize the all, user, all, or none, or a combination of these types of privilege on specific parts of database. So here we may allow to perform all the operations, or we may restrict to none of these operations or combination, just like read or insert, or update or read, or update and delete. So these can be the combinations where we can apply these combinations to the newborn, and then on the table, and then whatever users are there, they can access the database. Granting and revoking of privileges. Granting, it means that whatever the rights we are having, those rights can be passed to the new users. So this task is always done by a database administrator. So a database administrator is responsible for generating the privileges for every user and deciding the state of operations. So here, the SQL standard includes the privilege select, insert, update, and delete. The privilege, all privileges can be used as a short form for all the allowable privileges. A user who creates a new relation is given all privileges on that relation automatically. Okay. Next, SQL data definition language includes commands to grant and revoke the privileges. The grant statement is used to confer authorization. The basic form of the statement is, so here this is the type of the query, grant. After the grant, we can pass just like read, insert, whatever the rights we wanted to pass, or list of the rights. Then on, here we can pass the relation name or view name, and to, we can pass the users list. Okay, so this is how we are passing the grant, or we are passing the rights or privileges to the next lower level. So here, this point I will not take into much more detail. Okay, let us read this. The privilege list allows the granting of several privileges in one command. Okay, so several just like read, insert, etc. we can pass into single command. The notions of sorry, I forget to remove this. The select authorization on a relation is required to read tuples in a relation. Uh, so here, this is a grant command given. So grant select. Okay, we are allowing the select read operation on department relation. Two, there are two users, Amit and Satoshi. So these two people to whom we wanted to pass this right as a select. It means they can read the department relation. So it means Amit and Satoshi can execute multiple select queries on the department relation. So this previously was regarding the select. So now this is regarding the update. Next, insert authorization. So here, grant it means that we are passing some right to the other user. Now consider, what if we wanted to take back that right? Okay, consider I wanted to insert data for the 90 students. So some rights are given to me. After inserting data, that right should be taken from me so that I cannot make the further changes. So for this purpose, we can revoke or take back the rights which are given, or which is also called as restricting those rights. So for this purpose, again, we can use the same syntax, revoke keyword, to which we are passing the privilege list on a relation name or view name we can use, and after the from this here we can pass the users list. Okay, so user, just like for the previously I whatever rights given to the Amit and Satoshi were there, if you wanted to remove this rights here, so here we can write the command revoke select on department from Amit. Okay, so whatever select right was given, we can take back that right. So to revoke privileges that we granted previously, we write. So here, yes, here only example is given. Revoke select on department from Amit and Satoshi. So here, revoke update on budget on department from Amit Satoshi. So here, whatever this type of query is there, update and in bracket column name. It means that Amit and Satoshi can only perform changes. Okay, update it means that performing changes only on the budget column only. What are the remaining columns are there? ID, name, department. To those, Amit and Satoshi cannot change. Only budget column they can update. And by using this command, we can take back the right also. So read the statement for the ones.
Ma'am,
Yes.
can you show it on like my admin? Means it is very easy to understand there, means practically.
Yes, I know it is very easy to understand, but right now I don't have database. Database is installed here, but there is no data inserted here. That's why I cannot show this command. That is
Okay.
the problem. During the next lecture, definitely I will show you.
Okay, ma'am, no issue then.
I will show you the implementation of all this index,
Okay.
this grant and revoke, etc. I will show you.
Yeah, ma'am, like what I'm supposing, like how it will.
No, no, no. I will check for the any platform and will show you these queries.
Okay, ma'am, no issue. Thank you.
I will show you these slides for the 2 minutes, and after that, we will go for the next point. So please read the slides. We are in the last phase of this chapter, that is third chapter. So please read the slides for 2 minutes, then we will move to the next slide. So let us see about the roles. Roles, it means that this is trying to refer to a group. For example, faculty is a role. It means there are multiple users are there which can access database with the same role as faculty. It means that all might be willing to have a same access of the data or same data rights I have to give to faculty 1, faculty 2. If there are 30, 40 faculties are there and the same rights I have to give, then individually per user I need to give those rights. So instead of that, whatever the categories or users fall into a single category are there, these will be treated as a roles. For example, student is also role. There are four deans are there. So four deans form a single role as a dean, HOD, then faculty and students. It means that all students will have the same access of data or same levels of accessing the data. So such types of roles also we can create and we can assign the access rights to such roles also. So here the statement says that role can be created in SQL as follows. So here create role instructor we can create. So after that roles can be then granted privilege just as users can. It means whatever the users are there, just like them, we can also pass the privilege list. And here just like a grant command is given here, grant select on takes to instructor. So this command will allow instructor to perform select on the takes relation. Okay. Roles can be granted to the users as well as to the other roles as this. It means just like grant dean to Amit. It means the thing is that Amit is made as a dean. Okay. So then create role dean. Then we can create another role also. So grant instructor to dean and grant dean to Satoshi. So in this way we can assign role to a user also. And similarly, thus the privileges of a user on a role consist of all privileges directly granted to the user and all privileges granted to the roles that have been granted to the user or role. Okay, so it means that whatever the rights of Amit are there, these will be exactly same as a dean's, and whatever dean's rights are there, these can be passed to the Satoshi. Okay, so it means that here reverse way also we can perform the passing of the rights. So this is regarding the today's lecture. So today's lecture was quite lengthier and covered much more content. So we started from the views. So after the views, we have taken transactions. After the transactions, we have taken integrity constraints. Then within the integrity constraints, we have seen constraints on single relation and which are the constraints. Then we have seen data types on data types and schemas for the SQL. And then we have seen the authorization, user defined types also we have seen. Then in the authorization, which are the types of the rights, just like read, write, or select, update, delete, etc. So these are the rights available for the every user, and granting and revoking of privileges can be done. So these are the contents we have covered in today's lecture. So let me know anybody is having any problem or doubt. So okay, tomorrow there will be a written test for the second chapter in the morning session.